Everyone, today I'm going to be presenting a Stage 2 science experiment relating to the material world unit, specifically focusing on changes of state. The inquiry focus for this content is how do materials change when heated or cooled. A good way to start this discussion with your class is to open the question to them and find out about past knowledge and experiences they have in heating and cooling. A lot of these answers and ideas will probably come from the kitchen, but that's great because that's where we're headed today. Our experiment is called Let It Freeze, and we'll be investigating if all liquids freeze when placed in a conventional freezer. We'll be using a number of liquids today. You can add to these or change these with your classroom, but today we'll be using oil, vinegar, maple syrup and lemonade. We'll also be using 4 of these small containers, a freezer, a tablespoon. We're going to be using gloves to handle the liquids, an iPad for a function for the timer, gloves and a laptop to graph the results as we see them. We'll go into the graphics of that later. Let's get started. In order to develop a hypothesis for our experiment, we're going to look at the variables first. The dependent variable, or what we're going to measure, will be if all the liquids can freeze in a conventional freezer. The independent variable, or what we're going to change, will be the types of liquids. That's our oil, vinegar, maple syrup and lemonade today. And the controlled variable, or what we need to keep the same, will be the amount of liquid we use. So that'll be 2 tablespoons. We need to keep the container that we're going to put them in the same, so that's the same style and the same shape. The location in the freezer also needs to be kept the same. So when we head there later, we're going to make sure they're all on the same shelf next to each other. We do all of these things to ensure it's going to be a fair test. We're also going to have some gloves on today. We pour the liquids. That's just making sure we minimise the amount of risk we can have and avoid any skin allergies that you or anyone in your class might have.
Here we take each liquid and pour 2 tablespoons into the container, making sure we have those gloves on.
Now that we've poured 2 tablespoons in of each of our liquids, we're going to take a marker and pop a label on each of them. This way we can ensure our results are as accurate as they can be when it comes to recording. So I'm going to pop an O on this one for oil, a V on this one for vinegar, an S on this one for the syrup, and an L on this one for lemonade. Let's head to the freezer. Now that the first 20 minutes have passed and we made our first observation, students have the opportunity to use the site MathsFun to build an interactive online bar graph. Here, in groups of 3 or 4, students can record their observations. Together, the class will discuss the terminology that will be used here. So a 1 to 3, that would still be a liquid. 3 to 6, a half frozen state, indicating they observed some sort of change in the liquid, but they're not fully happy with the results yet. And a 7 to 9 being at that solid frozen state. Although the graph doesn't show exact results, it's enough data for students to use for their discussions later on. As well as the graph, students will be using their own iPads to take photos of each liquid.
Here we have some photos of the containers taken after the first 20 minutes in the freezer. As you can see, the labels that we made earlier make it really easy to tell what liquid we're looking at, so students can get ready to prepare on the graph. Here is just a screen grab from the MathsFun fight showing the bar graph. As you can see, they've labelled the Y and the X axis with the appropriate labels, and it's just a really simple way to keep track of the freezing progress. Again, after the second 20-minute interval, we take some more photos of the containers to see the freezing progress. A second bar graph is constructed on the MathsFun site to make comparison easier for results. Here are some photos from the final 20-minute interval showing the observations of the final product. Here is a screen grab of the final graph made to show the results, where we can see that the oil did not show much progress over the experiment and did not freeze, where the vinegar, lemonade and syrup all froze, especially the lemonade, which was frozen solid.
Now that the 60 minutes have ended, the containers are out of the freezer and students have finished their final observations on MathsFun, it's time to begin the discussion. A lot of things might arise here, including why the liquids that froze the fastest did, why some of the liquids didn't freeze at all, other liquids that students might like to see in another experiment that they think would freeze faster than the ones that did today. Some students might begin to look at other states of matter, begin to think, would these liquids heat at the same rate? This could be another potential experiment if you have time in your class. Extension students might begin to break off here as they start to use terminology like molecules. All of these points come back to the change of state that the liquid's had from a liquid to a solid.
The digital technology syllabus is also applied in this experiment, where again in stage 2, students use digital technologies to represent and analyse data. This is where collecting, assessing and presenting different types of data use simple software to create information and solve problems. For example, selecting appropriate formats or layouts for data, using software to sort and calculate data when solving problems. We utilise technology in this experiment with the digital timer on the iPad, as well as the digital technologies using the interactive graphs on Maths Fun.